types of reactions lab. Okay, you guys should have a lab paper in front of you. Okay, the objective of this lab is to observe different types of chemical reactions, to classify chemical reactions according to type, and to write balanced equations for each of the reactions. The equipment that we're going to need is matches or a lighter. You guys will just use your Bunsen burner and striker, and whenever you need to light your wooden splint, you'll just use your burner that you guys have at your desk. Okay, you need a 50 milliliter beaker, a ring stand, a scoopula and or a microscoop, a balance, which is in the lab, the wood splint, burette clamps, universal indicator, a glass stirring rod, and a 1-hole stopper with a bent piece of glass tubing. And then you should have 3 separate test tubes, and make sure you don't mix these up. You're going to have a large test tube, a medium test tube, and a small test tube. So when you're performing the experiment, be sure you have the right test tube. Okay? And if it doesn't look like you have them all, they should all be stacked together like this. Okay, so our first reaction, number 1 on your lab sheet, single replacement reaction. What we're going to do here is we're going to react magnesium with hydrochloric acid. So what we want to do is we want to fill a clean sized medium test tube about halfway full with the hydrochloric acid. The hydrochloric acid will be in the fume hood. It won't be at your desk. Please do not take the whole bottle of hydrochloric acid to your lab station because other people will be looking for it. Take your beaker to the fume hood and only get as much hydrochloric. Okay. And then have your large test tube ready to collect the gas that's formed. So what I'm going to do right now, because I know this reaction goes pretty fast, I'm going to go ahead and light my burner real quick. And we'll see if this lighter works. Almost. If not, there we go. Okay, and again, I'm lighting my burner now ahead of time because when I produce the gas, there won't be a whole lot of time afterwards to go ahead and to light your burner without losing the product that you produced. And make sure your burner does work right. There we go. A little bit more. Okay, and that will work for us. Okay, so again, medium-sized test tube. Okay, we've got the 3 test tubes. We're going to take our medium-sized test tube. I put my hydrochloric acid in a graduated cylinder, but again, for you guys, you'll be using a 50 milliliter beaker. It's filled about halfway full. And then what we want to do is we're going to put our piece of magnesium in it and quickly place the large test tube upside down over the medium test tube. And you want to record your results. You want to pay attention to what is happening, what do you see when this magnesium is reacting. Okay, so a piece of magnesium will be at your desk. Drop that in there. And right now you should be observing a reaction taking place. I want you to record everything that you see. I want you to look above the liquid to see if you see anything interesting as well as in the liquid. And what we'll do is we're just going to hold this here right now, wait for it to react. You can go ahead and wiggle it around a little bit or swirl it around, but again, be patient. The reaction is taking place. And then have your wooden splint ready, and again, make sure your burner is lit so you can go ahead and ignite the gas that you are producing. Now, another thing I want to remind you guys, and make sure, a lot of students will make this mistake. We need the liquid that's in here after the magnesium is reacted. We need that liquid in there. Do not throw it away, because if not, you won't have one of the reactants for a later part of the experiment. In with my acid, and right now it's reacting. Okay. I see bubbles forming, and that would be the gas that I'm producing. And We'll wait a little bit for this test tube to fill up with the gas. So what I'm going to do is I'm going to move this test tube away. Do not turn it over because you'll lose your gas. You want to do this quickly. And that's called a barking dog. So that's part 2 of the experiment, a combination or synthesis reaction that you just saw there. Now when you do that, what I want you to do is I want you to look inside this larger test tube and see if you notice anything. How did it look before? How did it look after? And again, record those observations in your notes. Okay. If you still have some magnesium left and you want to do that again because you have plenty of time, feel free to do that. But what I want you to do if you're going to do that is blow in there, and the whole idea is we want to get more oxygen inside here, so when we collect this mystery gas that you have to figure out, that it will have something to combust with. Okay, if there's no oxygen in there, it's going to be like a church candle where when they take the little cover that puts out the church candle by suffocating with carbon dioxide. So we want plenty of oxygen in here in order to ignite this mystery gas. Okay. And I'm going to try it. And again, remember, I'm reminding you again, please do not throw away the liquid in this medium-sized beaker. You will need that for a later part of the experiment. And if this next time is not as impressive as the first time, it's probably because I didn't get enough oxygen in there. But let's give it a shot. So again, with my wooden splint, we'll see. Yeah, see. So it didn't work that time. But you guys might have better luck. I still have the magnesium reacting, so I'm just going to set that there and in one of my graduated cylinders, and just be careful not to knock that over because again, we do need that for a later part of the experiment. So far we've done procedure 1 and we finished procedure 2, which was our combination and synthesis reaction. Now we're up to part 3, double replacement reaction. Okay, so what we need here is we need a magnesium chloride solution and some sodium hydroxide. So pause there because I have sodium hydroxide. So now we're on part 3, double replacement reactions. Okay, for this part you're going to need sodium hydroxide. You won't need a whole lot. The sodium hydroxide will be by the scales at the front of the room. Tap it if you have to, and then you'll only need a few pellets, and you guys can either put them in an Erlenmeyer flask, or if you want, you can get another 50 milliliter beaker out of your drawer. And again, you're only going to need about a few pellets. Maybe we'll say 5 pellets. Do not grab these. I know they look like Tic Tacs, but if they get on your hands, they're going to make your fingers very slippery. And later, if you guys pick your teeth, you guys are going to taste a nasty, bitter taste. The other thing I'd like that you screw this cap shut, okay, because sodium hydroxide is deliquescent, which means that it absorbs water from the air, and if we leave this cap off this, it'll turn into a thick slime, okay, and then it's harder to work with, especially when we need to get out just a few pellets. It'll basically make it stick together kind of like old Lifesavers. That would be a good way to describe it. Or if you guys have had very old Jolly Ranchers to where when you try to unwrap the wrapper sticks on. So that's kind of how this gets. It doesn't stay hard, it gets really gooey. Okay. So please cap it tightly. Okay, so I've got a few pellets in here, okay, and you can go ahead and use tap water for this part of the experiment. The original experiment used deionized water, however our deionized water machine in the back is not working, so I'm basically cheating by using tap water, but the experiment will still work out fine. So swirl it around, make sure that the sodium hydroxide is completely dissolved. Okay, we want to make sure that it's a clear solution. And so you can go ahead and read ahead while you're swirling that around. That's what I'm going to do right now. So we've got our deionized water. We added 5 pellets of sodium hydroxide to the mix. I'm swirling it, but if you did happen to use a 50 milliliter beaker, you could stir it with your glass stirring rod. But I like the Erlenmeyer flask because to me it seems more convenient. And then using the magnesium solution that we made in part 1, okay, and I know you didn't throw it away because I told you not to, you're going to measure out 5 milliliters of this magnesium chloride that you saved, and you're going to pour a small amount of this in with the magnesium chloride in another test tube. And what I need you guys to do is pay attention to what both solutions look like before you mix them together. Okay, this one is almost there, and as you can see here, my magnesium chloride, my magnesium has dissolved, and now I have a magnesium chloride solution. And so it said small test tube. So what I'm going to do is I'm going to fill the small test tube about halfway full with my magnesium chloride, and again, make your observations. Look at it. Do you see anything in there? Is it clear? Okay, describe what you see. Okay, now our sodium hydroxide solution, again, pay attention to what it looks like, see it, note what it looks like. Does it look clear, or do you see anything in there? And then finally what we're going to do is we're going to mix these two together, and then notice any changes. Okay, and in this case I do see a change. I'm not going to note it too because I want you guys to note your own observations when you guys do it in the lab, but there was obviously a chemical reaction that took place because the two clear solutions that I mixed have formed a solution that's no longer clear. And again, I want you guys to write down your observations and tell me what you see. Also, feel the test tube and tell me if it feels cold. Does it feel hot? Did the temperature not change at all? So feel that. And then once you've noted your observations, we're done with this, you can just simply rinse this down the drain. Okay. Now, if your finger's still slippery, okay, if your finger's still slippery after messing with the sodium hydroxide, what I want you to do, and over by the broken deionized machine, we will have vinegar, okay? And so you'll just take a rag, you'll put a little bit of vinegar on the rag, and rinse your fingers off with it. The vinegar will neutralize the sodium hydroxide, and when you're done, your fingers should not feel slippery. If they do feel slippery, continue to rinse it off because the sodium hydroxide can be corrosive to your skin, and it doesn't burn like acid, but it'll make your skin kind of peel off, kind of like athlete's foot, you know. And so, and then likewise, I told you, if you guys pick your teeth later, you're going to notice a bitter taste that's not very good. So, bases taste bitter. I'll cover that later in here with you guys. Okay, now we're up to part 4, decomposition reaction. Now this reaction, I need you to be very careful and work with your partner. Please pay attention to what each partner is doing. Okay, and it says, obtain about 3 grams of sodium carbonate or baking soda and place it in a medium test tube. So what we're going to need to do now is we're going to need to take our medium test tube and we're going to need to make sure that it's clean and dry. Okay, so I'm pouring out the leftover magnesium chloride, giving it a couple rinses. Now, using a paper towel, and hopefully a previous science teacher has taught you how to do this, take the paper towel, kind of roll it up like this, and we're going to stick it down into the test tube to make sure that it's dry. Okay, we do not want a wet test tube, we want a dry test tube. And the easiest way I found to do this is when you're shoving it in there, just keep spinning it around in the same direction until it gets up near the end. And spin it. Let's see, and sure enough it is dry. You got it. Oh, no, not near the edge here, so you do that a little bit more. Okay, so now I have dry test tube, and again it said add about 3 grams of baking soda. Now at your lab station there'll be a little bottle like this that has the baking soda in it. Okay, an easy way to go ahead and get the baking soda into a test tube, and as far as weighing it, you're going to weigh it out on one of the scales in the lab, and you'll use like a piece of weighing paper because you don't want to put the chemicals directly on the scale. We don't have weighing paper here, but we do have scratch paper, so pretend that this is my weighing paper, and then I've weighed out 3 grams. Notice I'm folding the piece of paper this way, and I'm folding the piece of paper this way. And what I'm doing here is I'm making like a little cubby hole here, so that way that's where my baking soda will be. I'm going to tap in about 3 grams. But again, you guys will have the scales in the lab with you when you do it, so you can use the scales. And then, with your medium-sized test tube, crease it, hold it, and then just tap. And then our baking soda is now in our medium test tube. Okay, next thing that we're going to have to do is we're going to take the rubber stopper with the bent piece of glass, and we're going to place that on top here. Okay, and then I'm going to set that aside. Okay, and it says, using the burette clamp, secure the medium test tube to the ring stand at a slight angle from horizontal. Okay, so this is my better burette clamp. So put that on my ring stand here. You guys have a better view of it. And we want it at a slight horizontal angle. And I'll show you why here in just a second. If you have problems spinning or tightening the bolt for this burette clamp, sometimes you have to push down here in order to get it to lock into place. And this is what I mean by a slight angle. We want it just slightly tilted. Okay. And I want this to be tightened. And there we go. So that's what I mean by a slight horizontal angle. And again, this needs to be dry in here because we're going to make an observation later after we heat this, and I need you guys to pay attention to the new things that you see, or again, your observations. Okay, next what I need to do is I need to get some water with some universal indicator. So we stoppered it, we did this. Now we're filling a small test tube about 3/4 full with lime water. If your lime water happens to be blue, that's okay. If your lime water happens to be purple, that's even better. But if your lime water is any color than blue or purple, there's a problem and you need to let me know. Okay, I like the purple one better because it goes through more color changes and it's more basic. The blue stuff is a little bit more dilute, and so it has less color changes that it's going to go through. Now, what's making the lime water this color is the universal indicator. If after you put the lime water in the test tube, the color doesn't seem vivid enough or obvious enough, you can go ahead and take your universal indicator, add a couple more drops to make it more obvious for you. So again, we're going to fill it about halfway or 3/4 full, three-quarters full. You don't want to fill it up too much, because if you fill it up too much, then when it bubbles, it may bubble over. It's not going to make a big mess. I mean, lime water won't hurt you, so it's not like a safety issue, but it's better not to have to clean up a mess than to have to clean up a mess. So I've got my 3/4 of lime water in here. Now when I'm looking at it, it does look very, very dim. So I know this looked very purple, but because this is such a thin test tube, to make it more obvious, I am going to put a couple more drops of the universal indicator in there. And again, this stuff is not dangerous, so you can just put your finger over it and do this. And now you notice the lime water is obviously purple, so it's very, very easy to see a color change. So again, it's up to your preference. I personally like to see the color change. Okay, so now I've got my test tube 3/4 way filled. One partner, and this is where I need you guys to cooperate with each other. One partner is going to hold the lime water with the test tube clamp as shown by the teacher, me, and with a medium flame, the other lab partner is going to heat the baking soda, and you guys are going to record your observations. Again, note how it looked before, and note how it looks while you're doing the experiment, and then note anything that you have to do after. Okay, and we've done an experiment similar to this early, so you should see something familiar happening to the lime water. Also, be sure to observe evidence of another gas by its condensation, hint, hint, that is formed at the stopper end of the test tube. Okay, so let me see if this burner, I might have to switch burners because this one's hooked out. So I'll be back with a better burner. This one is not good. Full blast. This burner's not that much better, but it'll work. Okay. So now that we've got our burner going, we've got our test tube at a slightly horizontal angle, and I've got my test tube 3/4 the way filled with the lime water. One lab partner is going to hold this lime water like this. We want the glass tube to be submerged so that way the gas that's produced in here bubbles through the lime water. And the other student is going to take their burner and they're going to move it back and forth like this. Okay. And the person who's moving it back and forth, I would like them to go ahead and note the color changes of the lime water and note what you guys are seeing. Again, you're recording your observations for this chemical reaction. Now, looks like mine might boil over, but it's pretty close. I'm doing it. As you guys can see, the lime water is changing. Now, I'm going to do something right now I want to make sure that you guys are careful not to do. Whenever you guys are done and you see that the color has changed and it's no longer changing anymore, it's important, it's very important that you remove this test tube first before removing this flame. Okay? Again, it's very important you remove this test tube first before removing the flame from the baking soda side of the test tube. If not, and you have this set up and the lab partner pulls this flame away, this is what's going to happen. And I don't want to have to lose test. Okay, so if you waited, it's going to make me a liar. Come on. Okay, any day now. Okay, slowing down. Well, okay, so let's try this again. So there's a blooper there. Be sure to remove this test tube before you remove the flame. If not, you could have a problem that's happening. Okay, I'm going to cheat here. Oh boy. Okay, well that's good that it didn't do it. I'm going to cheat a little bit. Okay, let's try it again. No. Heat this up. Bubbles. I remove it. Okay, I'm going to start this part over. I've only got like 7 minutes left. But I'm going to tell you guys what's supposed to.
It's cool. We just put we use the green screen.
Uh huh.
It'd be awesome. All you have to do is play the music and like lip sync to sounding
Right.
like the original song.
Well, what I'm thinking about doing, and I just haven't done it. If you remember hearing it, I think that it's degraded. Whenever I converted it up to the school webpage, it's not the same quality that it used to be. And I'm,
Yeah, I mean, showed us, yeah.
yeah, I'm thinking I'm going to need to actually redo it to make it sound like it used to, you know. And but again, I just haven't gotten around to it. But that is not a bad idea.
Music video would be awesome.
Okay, so I'm heating it. Okay, and so then if I remove my flame, what will happen is this will cool down, and when this cools down, it will produce a vacuum, and then the liquid that's in here will get sucked up and go backwards into there. And once that cold liquid hits this hot glass, this test tube ends up breaking, and then I'm out a test tube. Right now I can see it creeping up, creeping up, creeping up, and there it goes. And it's gonna drop down in there. There it goes. And right now you can see that it's blue in there. This wasn't hot enough at this point in time to crack it, but I have had students where they were heating it, the guy moved the flame down, and just like you saw here, the liquid, this will cool down, create a vacuum, and this liquid here will suck up through the glass tubing, and it'll deposit itself down there, and right when it hits that hot glass like that, you can see how it's still sucking the liquid in, because as it cools, more and more and more liquid flows. And then, in this case, I was lucky, the test tube did not break, but in a lot of cases, this test tube will crack and the bottom of it will fall out, and then you have a mess to clean up. So please make sure you remove this test tube before you remove the flame. Okay? And then other than that, for the rest of the lab, you're just gonna go ahead and answer your questions, okay, on the report sheet. And there will be a lab quiz that you and your partner are gonna take. So make sure you guys do the best you can with your observations and answering the questions. Don't just write anything down just to get the lab finished, because you and your lab partner will be taking a quiz using your lab paper later. Okay, so it's important that you guys take it seriously and do the lab the best you can. Other than that, that was the reaction lab. Thank you very much.